everybody. So this problem includes an important lesson, so let's give it a try. So we have this beam with a distributed load. So what's the first thing we do? Draw the free body diagram. Let me label this pin. I'll call the pin C and roller D. Let me pick coordinates. Okay, so there's a pin at C, which I will decompose. There's a roller at D. Okay, and then there's a distributed load here, which I will represent as discrete forces, just for the purpose of solving the reactions at the supports. Okay, so it looks like a rectangle and a triangle. So for the rectangle, I can replace it with one discrete load, which is the area of the shape. So 60 times 4, so 240 pounds, at the location of the centroid. So so 2 feet. Okay, now for the triangle, I can replace that with a discrete load, which is the area of the shape. So this is 1/2 base times height. So 180 pounds at the location of the centroid. So 2/3 of 6 feet, so 4 feet. Okay, so now that I represented the distributed load as discrete forces, I can solve for the reactions at the supports. All right, so in the x direction, that's it. In the y direction, cy d minus. Okay, and then that's some torque about anywhere I want. How about over here? Okay, so then there's torque from this negative in the negative z direction. Z is actually this way, right? Counterclockwise. So this would create a torque clockwise. So that's why minus 2 feet, 240 pounds. Then there's torque from this. So let's see. The entire bar is 10 feet. So here to here is 6 feet. Okay, so minus 6 feet, 180 pounds. And then the whole bar is 10 feet. So this would be plus 10 feet. D. Okay, I think I got everything. Equals 0. Okay, so let me point out the unknowns. Here, 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 here. Cx is 0. Solve this for D. Plug it in here. Then you got Cy. Okay, so at this point, we know all 3 reactions. So now, what do? We want to solve for the internal forces and moments at point A. So point A is 3 feet, like over here. So this is what you should not do. We don't want to cut through the bar here using this representation. That is not okay. We have to go back to the original with the distributed loads, and then we can cut the section right over here. So this is okay. This is not okay. Right? Not this representation was only to solve for the reactions at the supports. Once we're done, we kind of just leave this behind and we're back here. Then we can cut the section. Okay, so let's do that. So if I cut right through here, then it looks kind of like there's that section over here and then over here. And then let me draw all the other stuff. So right? If I cut it right here, there's going to be a distributed load like this. And then if we cut it right here, this side of this section will look sort of like this. Okay, and then there's CX, CY, D, and we know all these values. And by cutting it, we reveal the internal axial force, shear, bending moment. Axial force, shear, bending moment. Okay, now that we have these free body diagrams, we can continue solve for the three unknowns: axial force, shear, bending moment. So up to you which section you want to analyze. I feel like maybe this one looks a little bit simpler. So either way, there's no wrong choice. So I'm just going to move this off to the side. Okay, and then I'm going to focus on this one. Okay, so my coordinates were again like this. Oh, and then where was this? 3 feet. Okay, so this is 3 feet. And here to here was 60. Okay, so now that I cut the section, now I can represent this distributed load as a single discrete force, which is the area of the shape, 180, at the centroid of the shape, which it's a rectangle, right? So this is 1.5, just half of this. And let me just fill in all the other stuff. Okay. And here we go, right? Some forces. Let's see, we got CX and axial force. Y direction, we got CY minus 180 minus V. Is that it? Okay, that's it. Sum torque about anywhere you want. You can sum torque about here or here. Either way. How about on this side? I'm going to sum the torque about the right end of the section. Okay, so then there's torque from this. So that is, let's see, here to here is also 1.5 feet. So 1.5 feet, 180 pounds. And then there's torque from this in the negative direction, minus 3 feet. CY, which we would know the answer, right? We know this from above. And then what else? And then this couple, the bending moment. Okay, so then let me point out the unknowns here, here, here. And there we go. Solve for the axial force, solve for the shear force, solve for the bending moment. Okay, and then again, if you were to analyze this section, you would get the same answers. So maybe you can try that for practice. So real quick, just, right, see this rectangle you can represent as a discrete force. This triangle you can represent as a discrete force, and then all the other stuff. Right, and then for this free body diagram, you can write 3 equations and solve for these 3 unknowns, and you'll get the same answers. Okay, now, why did this problem show this? It was to point out that, remember when we did this representation solving for the reactions at the supports? And I said, point A, you don't want to cut through over here. you had to go back to the original and cut it through over here. Notice that this representation is exactly part B. So this is to prove to yourself that if you were to cut the section here, you would not get the same answer as if you cut the section here. So that's what you can try. So if you take this problem and then try and cut the section through A, let me just copy this over. Right, so let's focus on part B, this one over here. The free body diagram looks like this, here, right? And then A is right over here. If you cut that section, and I'll look at the left, right? Then there's and the 240 pounds over here, which is at 2 feet. And then all the internal stuff. Okay, look at this free body diagram. And look at this free body diagram. Definitely not the same. Okay, so if you continue to solve for these, you'll get a different answer for part B than you would for part A. So give this a try to prove to yourself that is indeed so, which is in itself the warning not to do this. Okay, so keep on practicing. This kind of requires a bunch of practice for you to kind of get the hang of it. So keep on going. Let me know if you have questions, and I'll see you in the next video.